I'm Llewellyn King, your host for MECFS Alert. We're very glad today to have as our guest Dr. Walter J. Koroshetz, Director of the National Institute of Neurological Disorders and Stroke at the National Institutes of Health. Welcome back, Walter. It has been, I looked it up, 7 years since we did one of these broadcasts, and I'm so glad to see you again. I want to ask you broadly, and do feel free to, if it's not comfortable, don't answer it if it's outside of your set of knowledge. But what do you think the impact of artificial intelligence is going to be on medicine in general? And it's already being felt, I believe.
Right. So it's a pleasure to be here, and I can't believe it's been 7 years, but we should do this more often. I have to, disclosure, AI is a little bit out of my comfort zone in terms of understanding the processes that go on there. But as everyone, and particularly here at NIH, we are learning quickly. I'd say it's a steep learning curve. It's pretty clear that the future is not going to look anything like the past because of artificial intelligence. And so I think the main point to know is that I think in medicine as well as here at the NIH, we're kind of beginning to learn, and we're trying to anticipate problems that might come up. We're trying to understand what the opportunities are, and the point there is that this is we're at an early stage, and whatever I said yesterday, whatever we do at a meeting, whatever we do today, we have to get started. It's obvious we have to get started, but be clear that 50 years from now, people will be laughing at what we did, when we started off, because things are going to change quite rapidly. I would say, in general, for the audience, the real potential of AI is to be able to take large amounts of data and make observations on those large amounts of data. And that data is so large that a human, a physician or a scientist, looking at the data on a spreadsheet will not be able to make really much of it, or might make, intuitive conclusions that are incorrect, that are not substantiated by the statistics. But AI allows you to do that. So I think the way to think about it is, on the one hand, it's a statistical tool. It's a tool to help you see things that from large databases that would not be easily apparent without these kind of tools. And so examples, you have, and the one we talk about a lot is your electronic health record. So you have data in your electronic health record, and if you're old like me, it goes back many, many years. And when you go to see a physician, in the old days, we would get, charts of people delivered to us, and there might be a stack that's, 3 feet high of paper medical records, and you'd have to go through them, trying to find out what the important things are for the patient that's in front of you. And that was inexact science, let me tell you. But that's what we did in the old days. Now, you have the opportunity with AI that can look at all the medical records and come up with, these are the issues that this patient has been having, and you prescribe this medicine, which may not be the best thing for condition X, which you kind of forgot about when you prescribed it for condition Y. And so these kind of automatic checks and automatic suggestions to the physician, I think, are certainly one of the first things that's going to happen. And you can do this now with AI because of this ability to look at all the data and with, say, generative AI, make logical conclusions from the data about what the patient's problems are. you go the next step, when you go and see a doctor, from a neurologist, and you ask the patient, what is the problem? How did it start? How did you do yesterday? What about the day before? And I always tell people when they're in training, what you want to get from the patient is almost like a videotape in your mind of the problem that they've been experiencing. So almost try and get enough information that you can almost in your head have a movie of what that patient is experiencing.
Walter, do we have a lot of data? Is there a large compilation of ME data or myalgic encephalomyelitis data, which can be mined to find what therapies have worked, what drugs have been effective, or what experience has been? What anecdotal material can be reduced to scientific reality in that data?
Yeah, well, I think that in general, the data that we need for AI was never created for AI. We had data, like I mentioned, paper records, or we get the history from a patient and it's written in a doctor's notes. So it wasn't generated to be used by AI. Although, so I think in the future, you could think that we would have an AI program that anytime a patient goes into a doctor's office, it's looking to see if that patient has MECFS. I suspect that many people have it and are not diagnosed. It doesn't come up to the doctor's attention. But if you can imagine, you have an AI that's listening to what the patient says, and not to the doctor doesn't develop this video in his mind, but the AI program is doing the exact same thing. You can make diagnoses that it could make before. Now,
I find out in my reporting that there's been a lot of progress made using AI in establishing prediction, a kind of predictive tool. For example, with Alzheimer's going 10 to 15 years out, or maybe 20 years out, what conditions in lifestyle or pre-existing, or not Alzheimer's, but other diseases, that one of which is osteoporosis, might lead to Alzheimer's. Do you think we will see such a breakthrough? Because that's a very useful tool. It's not a cure, it's not a therapy, but it's knowledge. Do you think we'll see something like that emerge for ME?
Yes, I think it will emerge. And I think, so if you look at the dementia space, there have been major advances. The first one was really biomarkers. So the biomarkers are very accurate now. The blood-based biomarkers are very accurate at predicting getting dementia within about 10 years from that. But then you put in the MRI scan, and then you have multiple MRI scans. You see change over time. Or you capture speech from the patient, and you see how their speech is changing over time. And these can all be put together by AI. So prior to AI, you'd have all this data, but it'd be in these little pieces, and you're trying to fit it together. With AI, it all fits together. That's the advantage of AI. It can look at multidimensional data. So in MECFS, the key thing is we need good data sets to train the models on. So the AI doesn't just appear out of nowhere, it's trained on data. And so if you have really dirty data to train the AI algorithms, it's not going to be very good. So what we really need in MECFS is we need really clean data sets. The other thing about AI is that when you have 100 patients, it's not that much more powerful. But when you have 10,000 patients, the human being can't handle that. AI can handle that. So the numbers and the purity of the data to train the model, and then you try to validate the model on another subset of patients. And once you do that, then you know what you're dealing with. So that's what I think we have to do in MECFS. We have to get that gold standard data. So, there is a paper that's been submitted, which is by Dr. Unamatz, who's developed kind of an AI approach to MECFS, looking at their T cell subsets, their microbiome, their clinical symptoms, and trying to put it all together. So it's Julia O. and Daria Unamatz is now in bioRxiv. So that I think is people could look at that. That's the beginning of what we need to do, I think, in MECFS. But all the patients came, I think, from one institution. So that's a start. But then you have to see how does that algorithm work in patients from New York City or Nevada. So you have to kind of build the algorithm, test it, refine it. And it keeps getting, the great thing about these algorithms is the more you train it, the better it gets.
And let's put aside, not very far, but a little bit put aside AI and take a look at where MECFS research stands at the moment at NIH. What has been the impact, for example, of long-haul COVID on that research? There was a lot of hope in the beginning because this extra funding came in. Have we made progress? Have we seen returns from that extra research?
Yeah, so that's the question we're tackling every day here. So let me just start off by saying that as one of the co-leads in that program, I went into it, 4 or 5 years ago with the idea that what we're going to be dealing with is MECFS, and that it's going to be a hard problem, and that we need to get pristine data. And with what we said before about the algorithms, training the algorithms, the key thing about the Recover program is that we have electronic health records from 60 million people. We have in-person longitudinal visits from 30,000 people, including kids, adults, pregnant women, the children born to pregnant women who had COVID. We have samples. I think it's like somebody said 237,000 samples. We have autopsy tissue, which we don't have in MECFS, so that people can go in and look under the microscope. And the truth of the matter is, these years later, nobody has a cure for long COVID. There are now some clues, and it's very similar to what we see in MECFS. So if you look at Dr. Nath's work at Intramural, he did studies in people with MECFS, he did studies in people with long COVID, and he sees a big overlap. And what we're seeing, most people are seeing, is evidence of chronic inflammation, which is not unexpected. That's what we had thought about MECFS. People have published papers where they see certain patterns. And that's also happened in MECFS. The stage we're at now is where we have to validate those patterns to see if they stick, or whether many of them were done in small groups of people. But now with Recover, we have samples from thousands and thousands of people, so we can have really powerful validation studies. We can bring in AI to look at this data, the results of the biosamples, the MRI imaging, what have you, in Recover. I would say, the thing about Recover is that most of the studies are showing that there's persistent virus somewhere in the body, and it's not totally clear, and that's the SARS-CoV-2 virus. Now, as you might know, years ago, Ian Lipkin spent a lot of time trying to understand if there's a virus in people with MECFS, was not able to find it, but this is not easy, this is not easy to find. We may have to go back and look again to see which virus this could be, if there's persistent virus again in MECFS. But most of the studies are showing that persistent virus occurs very frequently after COVID infection. Not everybody with evidence of persistent virus has long COVID, though. It's just that if you have evidence of persistent virus, you're more likely to have long COVID. And then people have found evidence of persistent virus, say, in the gut. And that's another area where, as you know, in MECFS, there's been a lot of evidence showing that there's a problem with gut and the microbiome. So those things are coming together between these two conditions. And then the issue of if you have chronic inflammation, you have chronic virus, why do you have fatigue and PEM? And that's a problem for long COVID. It's a problem for ME/CFS. So the hope is that we get some answers to these kind of mechanistic questions from the recover people that we can then apply to people with ME/CFS, whether it's COVID or not.
Do I read you correctly that in your own mind, long haul and MECFS are not the same disease?
No. Okay. So what I think, I think that long COVID cases that occurred after the infection, those are, I would say, kind of like infectious mono after EBV, right? And it takes a long time, people to clear the virus, people get better. The problem is that I think that there's a certain segment of those people who don't get better, and that is identical to ME/CFS in my mind. So the folks who have persistent trouble, and we have data now out to about 15 months in people enrolled in the trial, and a lot of people get better, but there is a significant subset that are not getting better. And
a lot of people get better from COVID and very, very, very few from MECFS. Is that correct?
Well, so ME/CFS is diagnosed, 6 months, at least 6 months. Many of the people, when you see them, they've been sick for years. Long COVID, I think that they have long COVID, but then the folks who don't get better basically have ME/CFS.
Okay, well, that's interesting. Now, just for general information, isn't it true there are a lot of viruses in the body that are never activated? And sometimes they are. I'm thinking of the herpes virus, for example.
Right. Yeah, so that's true that a lot of viruses, we can never get rid of them. They're in our bodies. Sometimes, wasn't clear about there's a virus called JC virus that turns out it's in everybody. You get immune suppressed, and all of a sudden it comes out and starts to create a terrible brain disease called PML. So there are lots of viruses in our body. A large percentage of our genome is basically it was contributed by viruses that affected humans and their ancestors going way back. So yeah, viruses have persistent effects. We have, as humans, been able, in most cases, to be able to live with those, but they can cause trouble when they get reactivated, for sure. And there are a lot of mysteries still in what causes that reactivation of different types of viruses and what its pathogenic role is. So in COVID, you reactivate a lot of viruses because the immune system is dealing with the COVID virus and allows these other viruses to pop up and become reactivated. But that's true about if you get influenza, the same thing will happen. Well, the question is, in influenza, everybody gets better and you reset. In COVID, maybe you don't reset. Not, there's clearly evidence early COVID that this EBV reactivation, not that clear that that's playing a role now a year later. But there's a lot of things we don't know yet.
Very soon I learned from my study of AI, and I'm not an expert, but I've interviewed an awful lot of people about it. I'm keenly interested in it. And I learned that very soon we'll get to a point where we can say to a computer, if the right program is in it, if the right agent has been activated, you can say to it, I really wonder what the next thing is in this. Or you can ask it a question. Walter, if you were asking a question of a computer, of AI, about ME, the first thing you would ask it, the first thing you want, what would be the next step in your research that you would like AI to help you with?
Good question. I think that, like anything else in medicine, you're always looking for the kind of killer experiment. And the killer experiment of ME/CFS would be someone who is severely ill and then gets better. The question in my mind would be, find that person or those people and tell me what do they have in common that might be related to the fact that they got better. That would be the thing I'd really like to know.
That's very interesting and very, it seems to me, a very logical way. Don't ask about the disease, ask about the cure, and you might find how it can help other people. One of the questions that I've had, and I don't know that it's ever been answered, is why do we have clusters, but generally ME is not considered infectious? And we know the clusters. We had in Pine Village in Nevada. We had upstate New York. We had the London Free Hospital. They're well documented. We know quite a bit about the clusters. So as far as I know, and please enlighten me if I'm wrong, we haven't been able to find a trigger for why in some instances this was clearly infectious and mostly it's not. Isn't that an extraordinary problem, an extraordinary challenge?
Well, I mean, you have to think about what causes clustering, right? And that's another great example of where you would like AI to kind of go in and see what do these folks have in common. But I would say we haven't been able to find an infection, but in long COVID, we have clusters in time because there was an infection. So I think the jury's still out on whether or not those clusters were due to an infection, and this is a post-infectious condition that occurred in some people who were infected, not everybody that was infected, and it might have been a strain. You know what I ask people, coronavirus is a common virus. We get it all the time. Question I always ask is, could coronavirus have been the cause? It's just a strain that, doesn't get you really sick, but it's a strain that somehow triggers long COVID. I don't think no one's been able to give me an answer about that one. Because it's a common virus, it's out there. You just need a certain strain that is more likely to make vulnerable people get long COVID. But that could be true of any virus, and that would account for the clusters. Now, but that's only one exposure. So the other exposures that are, there's probably a list of exposures you could put on that. You could put on that list, and it's the question is we've not been successful at finding that common theme, but there's got to be something there. So it's got to be some kind of an exposure, whether it's a virus or something, fungus or some antigen that triggers some immune response that leads to long COVID and MECFS. But I think what we know from long COVID is this is it's affecting millions of people. So this is not a rare event now in the general theme of infection leading to these kind of symptoms that persist, affect your immune system and persist for years. So we know it happens now. Now we got to figure out, what was the immune challenge in these clusters, and that's a really good another way of going about it. But the issue is, when you want to investigate a cluster, you want to investigate it as it's happening. That's the other beauty of COVID. We're investigating people who are just getting sick to see who gets better, who doesn't. The clusters, a lot of that work was done years afterward, right? So pretty hard going back in time, trying to sort out what happened back then.
In medicine, artificial intelligence is like a new frontier. It's a brand new tool. It wasn't dreamed of. You and I would not have talked about it when we interviewed years ago. It's an entirely new. What has it done to the temper of research? Has it given a sense of hope and dynamism that didn't exist? Is there a quickening of the pace?
Well, I would say this tool is so powerful, it enables things to happen that were never imaginable. Now, I want to just go back a second. 7 years ago, we should have been talking about because these tools were actually based, and if you look at the Nobel Prize winner, John Hopkins, he was a neuroscientist. He was studying how brain circuits work, and he then took that work to develop these neural network models which then have gone into AI. So it all started from brain sciences. And let me just give you one example. We work in trying to help people who are completely paralyzed, say with ALS, to be able to communicate. So we have people who do work, they put chips into the brain where the language area is, and they record the activity when the person is trying to talk, but they can't because they're paralyzed. But that brain activity for the last 7 or 8 years has been able to, get a computer to put words up at some very slow speed. What happened recently is they take that brain activity, they put it through a neural network, then they put it through a ChatGPT generative AI. That person now is communicating at almost normal speed. And so that's it's just so that's the beauty of, there's a single patient, but they're recording, thousands and millions of firings from the brain of the person and training the model. And it's just been like a miracle to see what's happened.
I wonder, we've never talked about yourself. What brought you to becoming a researcher rather than a practicing clinician? What was it about research that appealed to you?
Well, it's not exactly true, but not being a clinician. So I was, I always wanted to cure the world of diseases. So I started off, and I actually trained in internal medicine and took care of people with all sorts of different conditions. And then I specialized in neurology, and I did research that was related to diseases, epilepsy, Huntington's. And then after about 10 more years, I actually moved more clinically, and I was basically doing clinical research, clinical trials, particularly in neuroimaging, people with stroke and traumatic brain injury, Huntington's disease. I was the vice chair in charge of clinical neurology at Mass General. So I saw a lot of the patients that defied diagnosis and took care of a number of people with MECFS in those days, autonomic troubles. So I've had I kind of say I have ADHD for, biology and neurology. So I've had experience across a really widespread, not like when I did it, I tried to do the best I can. I got really deep into it, but then I did have a whole bunch of experience. I didn't stick in one place for more than 10 years.
It's very interesting. It certainly gives you a huge base. Is there any particular conclusion you draw about how we do medical research? For example, there are a lot of patients and advocates in the ME community who feel very, very strongly that it has been underfunded. And axiomatically, they feel had it been better funded, there might have been a cure or a therapy at this point. For example, we haven't cured AIDS, but we have a cocktail of drugs that hold it at bay. Do you think that's reasonable? Do you think that more money would have sped it up? And is more money necessarily the answer?
Well, right now we're in a really bad financial state. So right now, yeah, what we do, and this is something I explain. People don't like it, but the way that funding is done here at NINDS is purely an American system. So people on the outside have creative ideas. They submit grants. The grants get reviewed by their peers. For people who know MECFS, they're reviewing the MECFS grants. And then they get a score, and those scores are then percentiled from the best to the worst. And we pay the best scores until we run out of money. So we think that the future for, we have 400 different diseases in our portfolio, that the future really is based on the creativity that's coming in. And in general, unless Congress tells us, we don't favor one disease over the other. We're trying to solve all these. None of them are good. We're trying to solve all these diseases. We really rely on this creativity coming up. And the problem in MECFS has been the same problem with people getting care, that the medical community has not really gotten behind the effort to understand and treat people with MECFS. The research community has not got behind MECFS to put in the creative ideas like you need. And we have some really good people, but we have, I don't know how many, but it's not a lot of people who put their career into MECFS. When I came out, I put my career at the Huntington's disease. That was what I was going to do. I was going to really work hard on it, and I did. And we need that to happen at the MECFS. And that, I think, been the big problem. We can't fund that people don't apply. We get hardly any applications in the CFS research. So we need the applications. The applications come when people get passionate about doing something about a disease. And that's something the government, no matter how much money we put out, not going to do it. It's like people want to do what they really, feel passionate about. So for me, in Huntington's disease, it was the Huntington's community. Nancy Wexler was just this magnet for pulling scientists into work on Huntington's disease, and she nabbed me and convinced me. And so it's things like that. They're little things, but they make a huge difference if you can convince somebody that this is a field that they should work in. Now, the good news for MECFS is long COVID completely changed the ballgame. So people can't say, well, there's no such thing as a chronic post-infectious condition. That's not, they did that for years to MECFS patients, but they can't do that anymore. And so there you're right out in front. And not only that, but now you have primary care physicians who are seeing, lots of long COVID cases, because there's lots of them, and they look just like MECFS. So I think they're going to get better at that. And then the big question for us, for you and I, is can we convert these long COVID researchers to MECFS researchers? But I think we have a golden opportunity to do that now. We can't squander that. Well, there's a lot of activity in long COVID. We need to, and we have, so at NINDS, we put out calls for grants to study long COVID and the neurological effects of long COVID. And, those people are the people we hope are going to be studying the MECFS cases. And in our grants, we encourage kind of mixing and looking at MECFS and long COVID together, because they're basically chronic infection-associated conditions. So we have an opportunity now to change things. We got to make this work, though. We got to convert the long COVID research effort, which is lots of money, hundreds and hundreds of people. 15,000 people volunteered for these studies. So it's an opportunity to make a difference.
That's very interesting, and in a way it's depressing that we haven't gotten further, and in a way it's exciting that we may be about to do better. I would, as a neuroscientist, I would like to suggest, though, that a reporter who's covered a lot of science over his long career, that we really are at a threshold, and the future for medicine and for ME looks a lot brighter because of AI. It is as though billions of new brains were available to study this issue in ways they never could. Would you share in my hopefulness?
Oh, yeah, absolutely. And I just go to the back that this opportunity now is to get out there and get really clean data from patients, the symptoms, the samples, because what AI allows you to do is put things together like you never have done before. We have to get these pristine samples to train the AI algorithms on.
And also to remind us of what we've learned. For example, the off-label use of drugs. I always come back as an example to thalidomide. You wouldn't want to give it to pregnant women. It was horrendous when we did. But it's now helping with a lot of diseases. And AI would have identified those diseases probably much, much earlier because of its ability to look into dark corners of what we already know but have forgotten.
Yeah.
Walter, thank you for joining us at MECFS Alert, and I hope you'll come back, and good luck with your research. Out there in the ME world, people are desperately depending on research.
Yes.
Cheers.